Welcome to another stair building education series. Let's go ahead and jump right into it with our first video. Here's another outdoor stairway I come across and wonder why it was built that way, but understand that most of us look at something and they think, you know what, that's easy to build and that's a great idea, I'm going to do it the same way. And that's fine, but I'd like to put a little insight or at least share my opinion with you for this particular stairway. And it's quite simple. It's just built out of boxes. Usually I've seen people use railroad ties actually for this. 6x6s, 6x8s. These are 4x8s. They're 3.5 inches wide by 7.5 inches wide to keep the step at 7.5 inches. That's the maximum for most building codes will be 7 3/4 inches. If you're doing it for someone who has a difficult time walking up the stairs, you might want to use a 4x6. You might want to use something that's a little smaller, maybe 5.5 inches instead of 7.5 inches. And of course, there's a bottom view of it. Another view, give you an idea, just boxes stacked on top of boxes and filled with dirt. So in this particular stairway, this is just filled with dirt. I do not like this design because when it gets wet, and depending on the dirt, if it's sand, it's going to be difficult to keep in here. Sand's going to just spread all over the place. And if you get sand on the edge of this, and you're walking down or walking up the stairway a little faster than normal, this is going to be slippery. I do not like sand. And if you're going to fill it with dirt, you're going to run into the problem when it gets wet. This stuff's going to be slippery, and of course you're going to be tracking it all over the place. So dirt, not a big fan of. Now let's go ahead and take a look at a few more products: gravel, metal, tile, pavers, wood, and concrete. And of course, gravel is what you see this a lot. People fill it with gravel. And again, I understand this is easy to do. Build your square box out of wood, stack them on top of each other, and fill them with gravel. I see this a lot. Gravel is going to be difficult to walk on. You walk up and down a stairway in bare feet with gravel, you're not going to want to do it again. Not a big fan of that. Someone runs up the stairway, they're going to knock some of the gravel around. You're going to be filling it with gravel every once in a while or refilling it. Metal, not really a big fan of that. And of course, you're not going to see this. I just kind of threw it out there for someone who thought, you know, hey, I need a different look. Metal over time could rust, but of course you could get some metals, maybe stainless steel or something galvanized that's going to last a little longer. And this one here is tile. And if you're going to use tile, you're going to have to fill it with concrete. You're going to have something, some type of a base that the tile is going to adhere to. And most of the time that's going to be concrete for an exterior stairway. So if you're going to use something like tile, why not fill it all the way to the top with concrete and use some type of a decorative pattern, a stamp or something that they use to make the concrete a little nicer. And of course, pavers. Now, pavers would bring us back to the gravel. This is going to be something that will be a little easier to do. And if you were going to design a stairway using pavers, I would also recommend to build your boxes to where you can use pavers to where you won't have to do a lot of cutting. So you could see this wouldn't be that good of a width or a length. If this was a little smaller, then you would just have these here. So if you can kind of keep it in a pattern like this, that would work better. And of course, wood. You think about it, this is going to be wood. You could always fill this with wood, and I think you would be okay. And if you were going to use wood and wood for the box and wood for the steps, wouldn't be a bad idea to protect the area where the wood is touching the soil with gravel. Put a gravel spacer of at least 2 inches in between the wood and the soil. And again, this isn't a video on how to build this type of stairway. If you need more information on that, feel free to put a link in or a comment in the comment area and I'll see what I can do. This is a video on what type of materials you would use for your steps. And of course, in my opinion, concrete is going to be the best way to build this type of stairway. And that can simply be done by building your boxes, filling it up with gravel. And like I said, the gravel's a good method for keeping some of the moisture away from the wood, especially if you have an area where the water is going to drain away safely from the gravel. Wouldn't be uncommon to find a stairway. Let's go back here. Wouldn't be uncommon to have gravel, and if you didn't have any area for the moisture or the water to drain away from at the bottom, it wouldn't be uncommon to find the bottom step rotting and the top and the upper steps perfectly fine, because all the water is going to flow through the gravel until it hits this area here. So it wouldn't be a bad idea to put some type of a drainage system or gravel at the bottom to where the water won't accumulate in the gravel. Hope that makes sense. So again, fill the gravel up a little bit. Give yourself about 3.5, 4 inches. You can always use rebar if you want to. Fill it with concrete and you are done. So in this video, I will provide you with a design idea. One simple modification that you can do to create a stronger connection, a stronger structural connection for a set of stairs to a deck. Now, this is not going to work for an existing deck unless it was modified, or a deck that would be framed like this. But you can redesign the deck, and this isn't going to be that difficult to do. Simply redesign the deck, one small alteration, and you're going to be much happier, and you're going to save a few dollars too. So if I was to go with a deck like this and a set of stairs like this, you can see here where the stairway, it's not really connected well to the deck. And I've seen this plenty of times. People come in and they might put a board behind this and then nail a 2x4 on the side of it. And I'm not going to provide you with any ideas because I don't want to get you to go down that path. My job here isn't going to be to provide you with something that doesn't work, like this piece of OSB where somebody just takes and nails it to the side of the beam and then nails it to the stairway or to the ledger. And this again is another common. I've seen this done a variety of different ways. I'm not telling you this isn't going to work. All I'm saying is that this has a potential for failure. If you're working with an existing deck and you're looking for something to connect the stairs to, don't use a piece of OSB. It gets wet, it expands, it can fall apart. I'm saying it can. A piece of plywood can also fall apart. It can delaminate. If you're going to do something like this, you might want to use some boards and run them down. Maybe some 2x6 or some 1x6, something that is construction standard lumber. Use that to where it's not going, you're going to at least eliminate the chance of it falling apart. And again, I'm not going to draw it in here because this one here is bad enough. And by now you're probably wondering, what's the secret? What's the big deal? This is it. Just simply lower the beam, reduce the length of the post, provide yourself with more surface area to attach the stairway to. That's simple. Now, where do you save money in a situation like this? By getting rid of those expensive joist hangers and setting the joist on top of the beams. Now, another thing I just want to point out, I like using ledgers for my stairway, but this is probably going to provide you with enough surface area. What I don't like to see on decks, and it seems like this pops up more and more, is any areas where you have two pieces of wood connected to each other like this. Because what that does is it allows moisture to get behind it, in between the two pieces of wood, and it can actually absorb into the wood, each piece, and remain there longer. And if you get enough moisture over a long enough period of time, it's going to rot out either one or both of those pieces. So if you want to eliminate something like that, maybe you want to just connect the stringers directly to the decking like we have here. Just cut the stringers a little longer. Don't allow or deduct for a ledger. And if you don't like that idea, you want it a little stronger, add a joist hanger. I do realize they have other types of building hardware you can use that might work. This is just something that I've came across where engineers seem to use a lot of these on residential construction. And of course, that's what I've worked around, spent the most time around. Now, this method right here might produce a safety problem. Last thing you want to do is have a sharp edge sticking down from your deck. And I know you're thinking, hey, nobody's ever going to go around it. Whatever, I got you. But if you want to eliminate something like this, all you need to do is raise it up and then just simply cut a notch into the stringer. So if this is about 2 1/4 inches, just cut a 2 1/4 inch notch into the stringer. And that, my friends, is how this problem here is solved. You can save a few dollars by getting rid of the joist hangers, except for the ones you got to put in here. And you actually have a stronger stairway structurally. Here's something you are not going to see every day, and I believe this is about the first time I ever witnessed it. Someone sent me a picture, and it looks something like this. The edge of the landing, the front nosing, was located about in the middle of the doorway, and in reality it needs to come out to the edge of the door, and of course that would depend upon the width of the door. I think most building codes require a minimum of 36 inches, 3 feet in both directions, but of course that would change if you had a door, and I'm not familiar with those building codes. But realistically, the only way you're going to fix something like this will be to shorten the width or the depth of each individual step. And it's the only way I could think of fixing something like this. And it would be up to you to figure out if it's going to be even worth changing. And because sometimes you are going to create a bigger problem by, having a tread that might be a little smaller than approved by the building code. So you're basically trying to solve one problem, make the landing a little longer. But if you don't have enough room, you're going to be creating another problem by making the steps a little smaller or the risers a little taller. So let's just go ahead and take a look at what we got here. You can see here, these are 10-inch treads, 1, 2, 3, 4, 5, 6, 7. So we would have 70 inches between the face up of the landing at the top and the face of the lower tread if we drew a horizontal line. I'll show you more what I'm talking about there in a second. So this right here will give us 7 more inches. 7 steps. We take 1 inch off of each step, and we now have a 9-inch tread. This is an illegal tread according to most building codes, but you would need to verify that in your community or through your local building and safety department. If you're looking for a method to fix something like this, you don't want to tear apart the stairs, you could simply add incremental sections to the front of each step to create the new stairway. So we're at 7 inches here. We would need to add a 7-inch piece to the top, but only a 1-inch piece here. You would add 1 inches, 2 inches, 3 inches, 4 inches, 5 inches, 6 inches, and 7 inches to the front of the stairs to eliminate cutting a new set of stairs or building a new stairway. So something like this might work. Again, I'm just kind of throwing out an idea here. Something else you might want to do would be to remove one of these steps. So we have 7 here. 1, 2, 3, 4, 5, 6, 7. We have 5 foot 10 inches, which is 70 inches. And if we simply make it a little smaller, 1, 2, 3, 4, 5, 6 steps, if we can eliminate a step but that would increase the riser height, then that might be another option. But of course, this would involve tearing apart the stairway and rebuilding it. Now for the bad news, I would imagine that your stairway was built that way for a reason, and you might not have enough room to build a stairway that's going to meet local building codes. So let's just go over the building codes. 7 3/4 of an inch is usually the maximum height for each individual riser. And the depth is usually going to be 10 inches for a residential set of stairs for a private dwelling. Now, you would need to check with your local building department to verify that information. And I hate to say this, I wouldn't bring this to your building department's attention. I wouldn't say, you know what, I've got a problem here, because they could make you do some work here. So I'll leave it up to you whether or not you want to bring it to their attention. I have known people who have brought stuff like this to their attention, and it's cost them thousands of dollars. But I'll leave it up to you. You want to leave something unsafe or you want to fix it, do it right. That will be your final decision. Now, here's the distance I was talking about when I was asking the person in the email to measure between the doors. You know, if you have enough room here, this will determine your tread size and how many treads you'll be able to use. If you have 70 inches here, then you're going to be able to put 7 steps. If you have 60 inches, but you need 7 steps, you're probably not going to be building a safe stairway. So I think I've driven that point home enough. You would need to do all the calculations. If you need more help, I do have more videos on that, and a book on how to build a straight set of stairs that might be helpful. Of course, you might need the book, How to Build a Set of Stairs with a Landing, for this one. Here is another question that someone asked. They wanted to know if there was an easy way to check your long stairway to make sure that it's actually straight. And you could do it with a string. Just simply put a nail or a screw into one side of the stairway and put it in at the other side, and then pull the string tight, and then you can simply go up the stairs and see if the string is touching the tip of the stair tread, like this right here, or if it isn't. And if it isn't, then you have a problem. Now before I get carried away here, if you're within 1/8 of an inch or maybe 1/4 of an inch in the middle, that's probably not going to be a big deal. If you have 1/8 of an inch on one, 1/4 of an inch on the other, and then you're tight on the next one, then that could be a problem. But if you're off a little bit, then this could go back to what I was saying, to where you could have a sag in the stairway, or actually a crown in the stairway. And another problem could be that you miscut the stair stringers, the treads, or the risers also. So it's not just, I can't just say it's going to be one thing. You'll have to actually figure out what that one thing will be. So here's the stairway as it's built perfectly with a computer. Everything's nice and straight. But your problem with most stairways is usually going to be at the top or the bottom. And at the top, that could be as simple as forgetting to deduct for the ledger, which would create a situation like this, to where the last step is going to be a little longer. And then you're going to pull your string tight. Your string is going to be tight. It's just not going to be straight. And again, this could be caused by a few other problems with the stairway. So here we have our bottom straight line, but yet when we pull it tight, it's actually straight all the way to here, and then here, and then it angles back to here, which, using the first method, would give you the impression that everything's fine when it really isn't. So you can see here where if we brought this out a little further and then use this point, then we wouldn't have a problem. And I'm not about to suggest that this problem couldn't be found by simply measuring the depth of the stair tread and the height of the riser, because it can be. You just simply measure it and find that problem. But in order to figure out if the stairs are actually straight and are not sagging, they're not dipping in the middle or crowned somehow in the middle, then you might want to use this method here, to where we attach a block at both sides of the stairway. And of course, both of the blocks will need to be the same size and in the same location. So you're not going to want to put this block back here or have it extend further. Needs to be at the front of the tread, lined up, same height, in which we're using a 1-inch block here, 1 inch by 2 inches. And then we attach our string to that, get it nice and tight, and then use a block to check, the same size block, to check everything. So this isn't that difficult. We don't got to measure anything. We just simply slide the block into position here, and we can see we've got a problem. And if you remember, the problem, of course, is at the top of the stairway. The top tread is cut a little longer. But if it wasn't, then it would look something like this. All of the edges of the blocks would line up and everything would be straight all the way down. So again, any variations, if you take the block and you have it right here and it's off 1/8 of an inch, you're going to know then that there's a small variation. If you take the blocks and you put them on the front of each tread in the same position and everything is right on the money, then you know you have a straight stairway. Now, if the stairway is sagging, you can always raise it up. You can always, if of course, you can put a wall underneath it. If the architect has it designed to where there is no wall underneath it, they don't want a wall underneath it, then you're going to be stuck with what you have to deal with. So that is it for this video. If you check your stairway, and like I said, and it's off 1/8 of an inch or 1/4 of an inch, but everything measures the same. It's nice. It's easy to walk up and down the stairway. I wouldn't worry about it. There are no building codes, at least I haven't found any yet, that require the stairway to be perfectly straight. They just require the measurements to be the same for the treads and the risers. Here's another one of those crazy stairways I have seen built before. Never built one myself. Remember, I am not an engineer. I do not guarantee that something like this will work. I mean, the last thing I want to do is provide you with something and tell you that you can make this 50 foot long. I cannot guarantee that. Would something like this hold up if it was made out of 4 or 5 steps? I don't think it would be a problem. But when you get to where you're building a stairway that's even this size, it could be. And I would hate to tell you can build something like this without any engineering on it. Just ain't going to happen. So build this at your own risk. I'm just kind of throwing out an idea, something I think might work. And that, of course, would be bolting some large pieces of lumber together. And you can always put a few more bolts in. This has 2. You could put 3 or 4. You could put metal brackets on the back of it for some extra support. And of course, you could always put some braces under it. Maybe a wood post under it, the middle of it, for some additional support. That's where it would be the weakest. You build something like this, and it would tend to have problems more in the center. Or even, a couple of posts might be needed on longer stairways. Now, just simply a 8 by 16, this is 7.5 inches by 15.5 inches. Large piece of lumber, and just bolted together with some awl threads. And I think in the diagram here I'm using 1/2 inch awl threads. And you can just see there's a washer and a nut at each end. And again, like I said, you might need 1 or 2 more of these depending on the stairway. And of course, you might need larger pieces of lumber for something like this. Instead of something that's 15.5 inches, you might need something that's 16.5 or 17.5 inches. or even a little longer depending upon the step. 7.5 inches is pushing it for the riser height, and that might not even be something that would be approved on a public stairway. I think a public stairway is 7 inches. Private is 7 3/4. Keep that in mind. I do have other videos on that. You could attach the bottom into the concrete slab with another all thread and some type of an epoxy-based concrete system. And then, of course, you're going to want the nuts and the washers, or the top of the all thread, to be a little lower so that you can put plugs or some type of filler in there. I don't want people to be tripping over anything sticking above the top surface of the step. And again, like I said, throwing this out there, seen it done before, think it'll work, but you'll build this at your own risk. Let's go ahead and take a closer look at the block, what might need to be required. So here's what the all thread might look like. Of course, I don't have an all thread here. This is a bolt design. An all thread is threads all the way down. If you can get a bolt like this, it might work for you just fine. All threads are more common. And of course, bottom of it. Just wanted to give you an idea. Sometimes a few more pictures can help people out. That would be countersunk in a little bit to allow for the width of the washer. Top view of it here. And if you drill these holes the same distance, I think I have it here about 1 3/4 inches away from the edge, but yours might need to be different, might need to be a little deeper. And I did the same on the side here, and that everything lines up that way. But you will have to figure out where to drill these holes. And I'm thinking about doing a book. If I do, I will put a link at the end of the video for you, or in the video right around here, if I do make a book on different types of crazy stairs like this that people have built over the years. Welcome to another one of our videos. In this one here, we are going to answer a question that was sent to me. The individual is going to be working on the bottom step and trying to shape it and put a little angle on it for decoration. And you can do that as long as you're not encroaching into the minimum area of your building code requirements. So the information in this video, even though I'm going to focus on this one here, it's also going to apply to other types of stairs. Just wanted to point that out. So we have a set of stairs that comes down to a landing with one step. And the individual wants to shape, they want to angle this off here. And you can do that as long as it's on the other side of the minimum distance required by the building code. The building code usually requires, for residential stairways, to have 36 inches. Residential stairways are usually stairs that would be in a house or some type of a dwelling where people would live in it. So 36 inches is the minimum, usually going to have 10-inch minimum tread depth, something like that. So the step, the decorative portion of the stairway, can go on the other side of this, just can't go in that area. So let's just go ahead and put our handrail in here, and I just kind of drew a flat area. It's kind of the area on the other side of this is the area that's going to apply to our building codes. So we can add something to the other side of it like we did here. And of course, we could always add something to the other side. We still have our minimum distance required by the building department. Now would be a good time to point out that even though I'm suggesting this is my interpretation of this. This is what I've done as a stair builder. Now, I do have to say you would need to check with your local building department, building authorities, to verify this information. If you're in another country and you're watching this YouTube video, and you're thinking like, hey, I'm going to go ahead and do that. No, it might not work if you're in another country or even in another province or state. I'm in California. This is usually, or I should say, I've never ran into a problem doing it this way, but I can't stress this enough. if you're designing a house, you're doing something, you want to get a little fancy, thinking outside the box, it's always going to be good to check with your local building authorities. And of course, this can apply to other shapes. You can bring the step out a little further, not going to be a big deal. You can use these shapes here. So we can have it square, just extend it, or we can have it angled off, or we can have an angle coming out a little further. So on the other side, like I said. Now let's go ahead and remove the hand railing lines or guidelines that I had there and give you an idea of the tread going all the way across. I know I had it in sections here, and that can be confusing, but this would be one solid step. So something like this is fine. We have our line that would be over here. This is on the other side. Something like this could be a problem. So the building codes require the farthest projecting point forward. So if you have a nosing on the top of this, a section of the step that protrudes out an inch forward, you'd be measuring from that, the farthest point forward. So in this case right here, the farthest point forward is going to be the riser, face of the riser. If I measure from here, or this point here, the back corner, to here, and 10 inches is my minimum building code depth, I'm going to be fine in this area. I'm not going to be fine over here. If I measure from here and I got 7 or 6 inches, it's not going to work. Again, like I said, the minimum point that you have. Now, I also don't want to, there are stairs that you can build. So here's two scenarios. Let's just say that I took this and I made this 16 inches. My step here is going to be 16 inches wide. And you're going to step on here and then onto the landing. And then you're going to put your angled section within that 16 inches so that the farthest point from here to here is going to be 10 inches. So we're going to have 16 inches from here to here. And then we would still have our 10 inches from here to here. That might be okay with your building department, wherever you're at. Just another, I'm kind of just throwing that out there as something that might be okay. It also might be okay if you made this longer. Let's just say that you made this section of the stairs. If I measured from here to here, if I drew a line out here, just drew a line out here and made a point, and this was 4 inches. So 4 inches from this side, 4 inches from this side. And in order for this to work, all I would need to do is make my landing 4 inches longer. That way, if I had this at 40 inches and I measured from here, this point, straight over to this point, and then kind of came down and then out and it met here, then I would have my 36-inch minimum. I'm not sure that either one of those scenarios will work, but I just wanted to provide you with the options if that's something that you might think about asking your local building department to see if something like that's okay. So I've never done that before. Everything that I've ever done has been on the other side of the minimum requirement, as I mentioned in the video. In this video, I'm going to provide you with a few examples, different examples of a stairway and what stairway will be accepted and which one will not be, referring to the International Building Code Book 2018. And I will put the pages and the numbers of those building codes in the video description area for those looking for more information. And if you have questions, feel free to leave them in the comment area about the video or measurements or something I might be able to help you with. So let's go ahead and get started. The minimum building code for the tread depth is 11 inches and the minimum rise, I believe, is 7 inches. And that's actually what I did. I just created a block of wood here to make everything simple. And you can always check your stuff with a block of wood or a framing square. And I think that's actually made a previous video on that, checking it with a framing square. But this is just a block of wood, 11 inches by 7 inches. And this right here would be acceptable. by most building departments for a public stairway. Residential stairways can be a little less. We'll get to that in a little bit. Now here's a stairway with a nosing. It has a 1-inch nosing, and the measurement is going to be from the front of the tread to the front of the tread on the stairway. And if you notice over here, the front of the step, the front of the tread right here is a straight line, and the front of the tread here is a straight line, no nosing. This one here does have a nosing, and this is also fine because it meets the building codes. I hope that makes sense. Front of the step or the front of the projection of the step in some cases, which is what we'd be looking at here. So it is not measuring from here to here. So we have an 11-inch block and then a 1-inch overhang. So we would have a 12-inch step. And this is, I understand this gets confusing to people when they are going to do something like this for a residential stairway. So this right here is acceptable. They actually have a clause or an exemption in the building code book to where 10 inches is fine for a residential stairway or a home that most people live in. But again, I'm just sending these out there. It's your responsibility to check with the local building department. They might not approve this stuff. It depends. These videos are watched all over the world. And of course, we're in the year 2019 right now, March of 2019. And the building codes could change and make this video obsolete. And of course, I will try and make another video if that's the case. So here we have front projection, 10 inches. We're fine here. Next example, we have a cutback or a setback in the stairway. So instead of having an overhang, we have a setback. An undercut is what we used to call them. So the front of the tip, the very tip of the stair tread to the very tip of the stair tread here is 10 inches. This is fine for a private or a residential stairway. However, this one might not be because it breaks another building code rule, and that is, of course, the projection of the nosing. It cannot be greater than 1.25 inches. So in this example here, we have 1 inch nosing, and then we have a 1-inch undercut. So we have 2 inches here. The distance here cannot be greater than 1.25 inches. So even though we meet the 10 inches for the minimum tread depth for most residential building codes, we do not meet the nosing projection building code, which creates a problem. I hope that makes sense. So here we have another situation where we have a 2-inch overhang. And I've seen this before. People come in and here we have a 9-inch tread because we have a 2-inch nosing. I kept these measurements the same. We have 11 inches here. And the nosing projection here this is not going to meet the nosing projection building code of a minimum of 1.25 inches. It's 2 inches. And of course the tread, it's not going to meet the tread depth because it is 9 inches. Here we have basically the same thing, a 2-inch undercut. So from the tip of the nosing, we were breaking the projection rule for the nosing, and we do not have the minimum tread depth. And again, these are all stairs I have seen built, and they aren't as difficult to walk up, but they are difficult to walk down. And I believe I've stated that in other videos. So here we have a 9-inch stair tread with a 1-inch overhang. Again, this is probably something that's not going to make your building department happy. And here we have a 9-inch step with a 1-inch cutback. And that is it for the video. I tried to make it as short as I could. I could have made it shorter, I guess, but what the heck? This is what you're used to with my videos. So hope it makes sense. Any questions, feel free to leave them in the comment area, and I will answer them as soon as possible.